Welcome to this explainer. Today, we're diving into something that's probably sitting in your crisper drawer right now. We're looking at how a totally common vegetable might actually hold the secret to dramatically altering how we age. Seriously, we're going to explore some absolutely fascinating new research connecting what we eat, not just as basic nutrition, but as a direct signal to the biological clocks ticking away inside ourselves. Imagine extending your lifespan by a staggering 50%. 50%. That is exactly the astounding claim researchers observed in a recent longevity study. Now, to be clear, we aren't talking about human years just yet. But this massive jump in lifespan in biological models, it's got scientists incredibly excited. It's giving us a real glimpse into the mechanisms of aging and how we might actually, have the power to slow it down. Section 1. The secret in broccoli. So to figure out how this all works, we really have to unravel the mystery of sulforaphane. If you haven't heard of it, it's an organosulfur compound derived from cruciferous vegetables. Think broccoli, Brussels sprouts, cabbage. Now, for decades, we've known these foods are, good for you, right? Studies have linked them to reduced inflammation and less oxidative stress. But this new research, it shows that sulforaphane acts on our systems in ways that completely turn conventional wisdom about diet and longevity on its head. To get to the bottom of this, researchers turned to a classic biological model, C. elegans. It's a microscopic worm, and it's incredibly useful for this kind of thing because it has a super short lifespan, making it really easy to observe changes from birth to death. The methodology here was incredibly precise. The team synchronized the worm populations, so every single worm was the exact same age. Then, right at the start of adulthood, on day 1, they exposed them to varying doses of sulforaphane. And they didn't just sit back and watch how long the worms lived, they actually monitored their gene expression across their entire lifespan using advanced RNA sequencing, the whole shebang. And what they found was a very clear Goldilocks effect. When you look at the survival data, comparing the untreated worms to those treated with different doses, a specific pattern jumps right out at you. The 100 micromolar dose absolutely maximizes lifespan. That's where we see that median lifespan jump by over 50%. It's wild, but it's not a linear thing. If the dose gets too low, or conversely too high, those amazing benefits just drop off significantly. The absolutely crucial takeaway here is that more is definitely not always better. While that optimal 100 micromolar dose extended life beautifully, the highest dose they tested, which was 800 micromolar, was actually highly toxic. In fact, it led to a massive spike in mortality later in life. The researchers even noticed that at this super high dose, the worms exhibited fleeing behavior. Yeah, they were literally trying to escape the petri dish. So we're looking at a classic biphasic response here. A little bit works absolute wonders, but a lot does real damage. But wait, getting the dose right wasn't the only factor. It turns out timing is literally everything. This intervention only worked if it was applied early in adulthood. When the researchers started the sulforaphane treatment on day 1 or day 4 of the worms' adult lives, boom, they saw those massive lifespan extensions. However, if they waited until day 8 or 12, which is right around the time age-related decline normally kicks in, the treatment totally failed to produce any lifespan benefits. Zero. The window of opportunity to set this healthy biological foundation is strictly in early life. Okay, moving on to section 2, rewinding the biological clock. Let's zoom into the molecular level to understand exactly how this early exposure extends life. To do this, scientists created what they call a novel transcriptional aging clock. You can basically think of this as a highly sensitive biological odometer. But instead of tracking miles driven, it tracks the systematic expression levels of 311 specific age-dependent genes. By carefully mapping how these specific genes naturally dial up or down as a normal worm ages, they built a baseline model of the aging process itself. With that baseline set, they could take the sulforaphane-treated worms, run their genetic data, and essentially ask this biological clock, hey, based on your genes, how old does your body actually think you are? The results from mapping out these genetic profiles over time are just stunning. When you run the math and compare the treated worms to the untreated ones, something incredible happens. The 16-day-old treated worms actually group together with the 12-day-old untreated worms. Think about that for a second. The sulforaphane literally rolled back their biological clock by 20%. So chronologically, they were 16 days old, but biologically, at a systemic genetic level, they were expressing exactly like a 12-day-old. Which brings us to section 3, the power of hormesis. To wrap our heads around why a compound from a vegetable can literally roll back the odometer like that, we have to talk about a biological phenomenon called hormesis. This is a bit of a mind-bender. It's the reality that vegetables like broccoli aren't just sitting there providing passive vitamins. They are actually introducing a mild cellular stressor into your body, basically a very mild toxin. You see, in the wild, sulforaphane is just a plant's defense mechanism to fend off pests. When we eat it in low, controlled doses, it stresses our cells just enough to force our bodies to mount a massive, youth-preserving defense response. It's essentially like hitting the gym, but for your cells. So what exactly does that defensive response look like? Well, the RNA sequencing data showed that the genes most strongly kicked into high gear by sulforaphane are the ones governing our detoxification and metabolism pathways. We're talking about a massive system-wide upregulation, specifically the cytochrome P450s, which are the heavy lifters for phase 1 detoxification, along with glutathione S transferases and UDP glycosyl transferases, which handle phase 2. And here is the craziest part. Even though the worms only got exposed to the compound on day 1, this massive genetic defense response didn't actually peak until day 12. This delayed echo effect is just phenomenal. Deep into the worm's mid to late life, around day 16, the genetic data shows that an astonishing 57 to 72% of these critical detoxification genes are still heavily upregulated compared to the control group. They are fully turned on and working overtime. That early, day 1 exposure to a mild stressor essentially primed their systems to become robust, hyper-efficient detoxifying machines well into old age. Section 4. What this means for you. All right, let's bring this out of the petri dish and talk about practical reality. The big takeaway from all this transcriptomic data is a fundamental shift in how we need to view aging. If we want true geroprotection, meaning we want to actually extend our health span, those vital years we spend healthy and active, it's going to rely on global, whole-body defensive shifts instituted early in life. Modern medicine, bless it, often focuses on just slapping Band-Aids on isolated age-related diseases as they pop up. You know, treating a heart issue here, fixing a joint issue there. But this research strongly suggests that to truly slow the biological clock, we need systemic, early life interventions that ramp up the body's natural resilience from the inside out. I love how the researchers summarized the delicate, hormetic nature of this whole mechanism. They left us with this delightfully simple, absolute mic drop of a conclusion. Eat your broccoli, just not too much. It hits the nail right on the head. You want just enough of that compound to trigger your cellular defense mechanisms and prime those detox pathways, but you definitely want to avoid crossing that line into toxicity. It's all about harnessing that optimal, mild stress. Which leaves us with a really powerful final thought. Now that you know the food on your plate acts as a potent chemical signal, rather than just passive fuel, what small adjustments are you going to make today? How will you carefully stress your cells into building a longer, healthier tomorrow? The science is pretty clear. The biological clock can be slowed, and the genetic odometer can actually be rolled back. The only question is, how will you use the mild stress of your daily diet to rewrite your own biological timeline? Thanks so much for joining me on this explainer, and hey, I bet you'll never look at a piece of broccoli the same way again.